The noble metals are metals that are resistant to corrosion and oxidation in moist air, unlike most base metals. They tend to be precious, often due to their rarity in the Earth's crust. The noble metals are most commonly considered to be ruthenium, rhodium, palladium, silver, osmium, iridium, platinum, and gold. Other sources include one or more of mercury, rhenium or copper as noble metals. On the other hand, titanium, niobium, and tantalum are not included as noble metals despite the fact that they are very resistant to corrosion. Noble metals should not be confused with precious metals. Introduction: Palladium, platinum, gold and mercury can be dissolved in aqua regia, a highly concentrated mixture of hydrochloric acid and nitric acid, but iridium and silver cannot. Ruthenium can be dissolved in aqua regia only when in the presence of oxygen, while rhodium must be in a fine pulverized form. Niobium and tantalum are resistant to acids, including aqua regia. This term can also be used in a relative sense, considering noble as an adjective for the word metal. A galvanic series is a hierarchy of metals that runs from noble to active, and allows designers to see at a glance how materials will interact in the environment used to generate the series. In this sense of the word, graphite is more noble than silver, and the relative nobility of many materials is highly dependent upon context, as for aluminium and stainless steel in conditions of varying pH. In physics, the definition of a noble metal is even stricter. It is required that the d bands of the electronic structure are filled. Taking this into account, only copper, silver and gold are noble metals, as all d-like bands are filled and do not cross the Fermi level. For platinum, 2 d bands cross the Fermi level, changing its chemical behavior. It is used as a catalyst. The different reactivity can easily be seen during the preparation of clean metal surfaces in an ultra-high vacuum. Surfaces of physically defined noble metals are easy to clean and keep clean for a long time, while those of platinum or palladium, for example, are covered by carbon monoxide very quickly. Electrochemistry: metallic elements, including noble and several non-noble metals, the columns group and period denote its position in the periodic table, hence electronic configuration. The simplified reactions, listed in the next column, can also be read in detail from the Pourbaix diagrams of the considered element in water. Finally, the column potential indicates the electric potential of the element measured against a standard hydrogen electrode. All missing elements in this table are either not metals or have a negative standard potential. Antimony is considered to be a metalloid and thus cannot be a noble metal. Also, chemists and metallurgists consider copper and bismuth not noble metals because they easily oxidize due to the reaction O2 plus 2 a Sh, 2O plus 4 a She, a 4 a Shoa, Ac, plus 0.40 of E, which is possible in moist air. The film of silver is due to its high sensitivity to hydrogen sulfide. Chemically, patina is caused by an attack of oxygen in wet air and by CO2 afterward. On the other hand, rhenium-coated mirrors are said to be very durable, despite the fact that rhenium and technetium are said to tarnish slowly in moist atmosphere. See also, base metal, minor metals, precious metal, references. Notes. External links: Noble Metal, Chemistry Encyclopaedia Britannica, online edition, to see which bands cross the Fermi level. The Fermi surfaces of almost all the metals can be found at the Fermi Surface Database. The following article might also clarify the correlation between band structure and the term noble metal, Ha1 Kortegaer, E. O. Such, K. Making a noble metal of Pd. EPL 71, 276. Bibcode, 2005 EL, 71276 doi, 10.1209 I 2005-10075-5A.